Let's look at points of inflection. An inflection point on a graph is where the graph goes from concave up to concave down, or from concave down to concave up. It is possible for there to be no concavity change at a point, and we're going to look at a couple cases of that. Now, a point of inflection is defined to be a point where either the second derivative is 0 or the second derivative does not exist, and where the second derivative goes from positive to negative or negative to positive. So you need to check the following things. You need to find where the second derivative is 0 or where it does not exist. And then you need to check to see if the second derivative goes from positive to negative or from negative to positive. If the second derivative at that point goes from positive to positive, it is not an inflection point. Just like if it goes from negative to negative, it's not an inflection point. Let's look at an example. Let's find the inflection points of y to the fourth minus 4x cubed. Now the first thing you need to do, of course, is take the second derivative, which means you have to take the first derivative. Y prime, pen's not working, is 4x cubed minus 12x squared. Next thing you need to do is find the second derivative. Y double prime is 12x squared minus 24x. Now go on and factor this as 12x times x minus 1. So, let's try x minus 2. Having trouble with my algebra here today. Now, where does the second derivative equal 0? It is defined over the entire interval. Second derivative equals 0 when x is 0 and when x is 2. So these are the 2 points we're going to look at. These are the only possible inflection points. Okay, sorry about handwriting there. So now, let's take our interval. Let's look from negative infinity. Well, that wasn't very good. Negative infinity to 0. And pick a value. It doesn't matter what that value is. If I pick x equals negative 1,000, then the second derivative at negative 1,000 is going to be 12 times negative 1,000 times negative 1,000 minus 2. So it's negative times negative. So it's going to be positive. So we know that that means this is concave up. Now I don't have a lot of space down here, and I don't want to lose my derivative. So conclusion is it's concave up. Now let me change my pen color. The next interval is going to be from 0 to 2, and let's pick x equal 1. Y double prime of 1 is 12 times 1 times 1 minus 2, and this is going to be negative. So this is concave down. Our third interval is from 2 to infinity. And let's pick, I don't know, x is 1,000. I just really like that. In which case, the second derivative at 1,000 is 12 times 1,000 times 1,000 minus 2, which is positive. Now, the definition of an inflection point is when it goes from concave up to concave down, or concave down to concave up. So we can see the point x equals 0 is an inflection point because the second derivative goes from positive to negative. X equals 2 is an inflection point because f double prime goes from negative to positive. Now when I look at this problem right here, f of x is x to the fourth. Let's take the first derivative, and that's 4x cubed. The second derivative is 12x squared. Now, the second derivative is equal to 0 when x equals 0. However, this is not an inflection point. And why? Let's look at the interval from negative infinity is less than x is less than 0. So we're going to look at negative x values. When x is negative, f double prime is still positive. Similarly, when x is positive, f double prime is positive as well. So we don't have an inflection point because the second derivative does not change direction, change sign from positive to negative or negative to positive.